that is happening as much as we are talking about it in India. And that experience is what relates to the kind of performance that you're seeing on the numbers, especially when we have grown from maybe about $4 billion 4-5 years back to about $22 billion in the recent year. Almost maybe 55% to about 70% growth that we have seen. That said, we continue to witness that kind of a momentum worldwide, growing up to about $40 billion. That's the kind of guidance that we have given to the market. But most important, what you also would like to know is the fact that all of this is delivered by technology which is developed in-house, end-to-end. And it's important because when you're looking at any kind of a data center setup, you could possibly have one partner trying to bring all of the technology and lead that technology, but also maybe in situations there are close to about 20 partners or 30 partners and 40 partners. And that also gives the segue into how we are differentiated and what do we do in order to bring the best. One of the other points that you will also relate here is the fact that we have manufacturing facilities world over. When I say that, primarily in 3 locations. We've pretty much got US, Netherlands, Taiwan, and Malaysia all put together with a capacity close to what maybe about $70 billion to $100 billion kind of production that is capable at this point of time. And obviously we continue to go. Also the fact that when you look at all the gigawatt kind of announcement, data centers announcement that you have been witnessing even in this country, and I'm sure by 2030 you will see about 7 to 8 or maybe 10 gigawatts capacity of data centers being there. The only company which possibly has a reference of a 1 gigawatt factory or 1 gigawatt data center being set up is Supermicro. Of course, you'll get to hear more of how we have done it, what is powered it, what is the experiences that we have had from some of our colleagues, both from India as well as US. We continue to see this, not just worldwide, but also in India, as you would have seen. Maybe with that, we anticipate close to 200% kind of a growth in some point of time. I think we have spoken about the installed capacity or the kind of racks, number of racks. Maybe one of the important points that you would see here is our ability to sort of produce close to 6,000 racks, a monthly rack capacity. And when you talk about liquid cooling, maybe about 3,000 racks. And in fact, when you associate that with the kind of power consumption that we ourselves have from production, maybe that is the only limiting factor, but also the fact that I don't think many of those factories would even have that kind of a power to just produce. We are talking about 63 megawatts of power that we currently consume in producing those servers, racks, and data center infrastructure. Most important, when I mentioned that we've been in the business for close to about 20 years, you would have seen some of our partners present Supermicro solutions, and some of the partners that will continue to be part of this journey are highlighted in this. I'm sure there are many of you representing those companies in this forum, so many thanks for supporting us in the past, but also supporting us have that vision for the future for the next 5 to 6 years as we in India want to develop this. What you would want to also know us for in the context of the growth that we are seeing worldwide is our ability to differentiate, which I just spoke about, and that differentiation comes from all kinds of products and abilities that we have demonstrated, especially the data center building block solution that I wanted to highlight. We are possibly the only one which can bring in right from a server to a rack to CDUs, manifolds, even the chillers that are required, and hence end-to-end capabilities, both from a design, but also from a perspective of producing it ourselves without having dependency on any other assembly operations worldwide. And that itself gives us the power to adopt the latest that is coming from the semiconductor world. Many of you would be able to relate that it's no longer the semiconductor life cycle, or the cycles used to possibly be about a year or 18 months whenever they used to launch one product. Right now we are in a world where there is a launch maybe once in 6 months, or once in 8 months, or maybe once in 9 months, right? What it means is any server company, any AI infrastructure company will have to have that control on the ecosystem, the deep engineering capability that it has in order to quickly turn around that generation of semiconductor and the ecosystem innovation that is bringing. And in order to then turn around, produce those servers end-to-end capabilities, it has to have that control. So we are possibly the only one which has that kind of a capability at this point of time, and you will hear more from our colleagues. So with that, I would welcome my senior colleague, Vic Malayala, functions as the president for EMEA, but also the senior vice president, technology, and especially AI, to talk about the perspectives that we have seen globally, and how are we dealing with these perspectives both in India and worldwide. So thank you, Vic, and a warm welcome.
So one thing we realize is that we don't know how to put the slide decks, right? So for people who haven't seen it, it's basically about accelerating the data center infrastructure, right? So before that, I just have a question. How many of you are involved directly or indirectly on the server hardware? Very few. Thank you. And for the rest of you, I'm going to bore the hell out of you in the next few minutes, because we are going to talk about what is happening with respect to the data centers, and what is happening to the server infrastructure, and what is that we need to do, and what are the pitfalls, and how do we approach that problem together, and what Supermicro is doing to address this so that we can be relevant in this market. Okay. So first of all, when you're starting to take a look at the data centers, especially now, the biggest headache is the spend. You're talking about huge investments. You're talking trillions of dollars in terms of investments for the data centers. What does it mean? You take a look at any kind of deployments today. Historically, if people are talking about 20, 30 megawatts of data centers, that used to be a big deal. But nowadays, with the AI infrastructure, the spend is becoming bigger and bigger. So when people are spending that kind of money, there is a cost of money. People need to realize an output from that. When they are putting so much money on something, they have to recover their expenses. That's the first part. Second of it is, the same amount of money, if much of it is actually used in creating the compute demand, that is a better way of putting the money. And every one of us that are involved in the data centers in some shape and form know the biggest is not actually the money that's a problem. It's the available power that's the biggest issue. If you take a look at India today, the amount of power that is available for the data centers in the whole India is around 1.4 gigawatts, right? You can multiply with hours and come up with a bigger number to make us feel happy, but the reality is that is the power that we have. The good news is that there is a significant investment happening from different industries, and the government is supporting it, which actually will get us close to 7 or 8 gigawatts of power in the next 3 or 4 years. This is incredible. If you think about the amount of effort that goes in building a data center and what is happening in that actually quite excites all of us, right? So then, now it's so difficult, and much of the power is coming from non-renewable energy sources. But Indian government is actually pushing hard for at least certain percentage of it need to be based on renewable energies. Some of these companies are making based on hydro, some of them are based on solar, and some of it is wind, and how to ensure the baseline is established at a way where the usage of fossil fuels is limited on that one. So when you say, for example, you need money, now you have power, so when you do both of them put together, you put infrastructure in it, the first thing that everybody starts looking at is when and how am I going to recover this money? This is the return on investment that everyone talks about. Bottom line, what it means is that you need to be looking at optimizing things at every aspect of it so the money is put to good use and be able to recover that money. Let's say, for example, they have all this infrastructure. Companies like Supermicro provides that. They will put it in a data center, get the power, starts running. Everything is fine. Who is going to use that? This is where the off-takers are today, right? So we need to start looking at the applications that are going to come and how these applications are going to make people, their life better. This is where many of the people that are here in the room that are involved in some shape and form on the software becomes very relevant, because this is the one that's going to determine all the infrastructure that's being put together is put to good use, right? So looking at this equation, that's where the AI market is. Lots of money, lots of power required, optimized solutions are needed, the developers becoming an important play in this entire equation so that we can have a better result. Now what's happening with that? So we put all this infrastructure. Why do we need this large infrastructure? Mainly because, I'm sure every one of us in some way using ChatGPT, for example, right? Or Gemini or any of these Gen AI tools. If you take a look at the amount of compute that is needed to train these models, that's incredible. And part of it is related to the amount of data. And second is how long it takes to converge these models to have a meaningful model coming out of it. And what does it take to continuously improve and tune this? So if you start taking a look at it, what used to be like a 1.5 trillion parameters, that was like a big deal. But now, the latest one, if you're talking, which is, I think it's the new Grok model, it's like a 6 trillion parameters, right? And looking ahead, it could be 10 or even higher trillions of parameters. These models need to fit in the memory of these clusters of GPUs. That is what requiring a larger and larger GPU clusters that is required to train these models. The second of it is, these GPUs can be sitting in isolated pieces, or they can be connected using a very high speed, low latency interconnect fabrics. This is where the difficulty comes in. When you are putting all these GPUs and you need to figure out a way to cool them, this is where the liquid cooling is coming into the equation. Because normally what happens, you need to have some kind of fans that are blowing air over these components to take the heat out, so it will be staying operational. Other way is basically put some kind of liquid cooling. I'm sorry, I'm blocking the view perhaps. So if you start taking a look at what does it take for these things to be cooled, this is liquid cooled. And the power delivery point of view, historically you just take it and connect it to a wall outlet or maybe a 220 volts or something like that, the power supplies. But the larger ones require power delivery using the DC bus bar. So it's another thing that is changing. So we are talking about components that are running very hot, like 1400 watts and even 2000 plus watts very soon. And you're talking about rack level power that is required, that is much larger than traditionally what we are used to, and be able to cool all this thing in a better manner. This actually means that when you're building a mega scale data center, you start looking at things differently. Gone are those days where you say, oh, I have this data center, it's been 20 years old. My friend, it's not going to work. So either need to be retrofitted or you need to build something brand new. But the problem here is, if I start building a data center today, it may take a year and a half, 2 years to build it. By that time, the GPU kind of, the whole product profile is changing so much, it's already becoming outdated by the time you finish that construction. This is a big, big, big problem. So what people are looking at it is, how do you make this modular? How do you ensure that these are able to be retrofitted or be able to modified at the time of something to be rolled in? So today, for example, let's see, for example, this is an example of what is happening. Pandemic, like in a 2021 time frame until now, you take a look at it like 4 to 5 years. What used to be around 500 watts for either a GPU or a CPU it changed very quickly. What is going to be deployed in the very near future, like a Vera Rubin, I'm sure you heard of it when you're looking at NVIDIA GPUs, or AMD-based Helios. I saw that in their booth, a big rack, right? You're talking about 270 kilowatts on the rack level, but at the same time, if you take a look at a GPU, it's over 2,000 watts. These are liquid cooled and whatnot. But if you have a data center that need to accommodate it, traditional data center has no way of doing it. Luckily, in India, as I mentioned, much of the data center build out is happening brand new, and this is the reason it becomes very important for us to understand what's happening on that front. That way we can build it properly, deploy it clearly. Other thing what happens is traditional data centers may do 2,000 to 3,000 pounds, which is like 1,500-ish kilos of rack. Beyond that, if you start rolling on that, it may actually break the tile. Some of these systems are actually going to 7,000 pounds. So you can imagine a different level of, I would say, data center build-outs are needed. So we need to take that into consideration. If you take a look at the systems, this is how it pretty much looking like. You can see the red line, which actually going to like a 250, 260 kilowatts per rack. Per rack, a single system. When I say rack, is not even like 20, 30, whatever systems. All these are connected using fabric. This is a single system that's consuming like 260 kilowatts. If you think that is actually impressive, just wait for 1.5 years. We're talking about 1 megawatt per rack. Google has already announced that with the TPUs, they're talking about a megawatt per rack. How are we going to cool that? How are we going to give it power? All these things. So when I talk about it, we start looking at things beyond what's happening at a server level. We are looking at it in a holistic way. When they start getting deployed in a larger scale, what is that we should be looking at? Because think about it, we as the partners with NVIDIA, AMD, Intel, and several others, we have access to technology, and based on that, we can start building. But the data centers, their job is different. I mean, they could be coming from real estate. They could be coming from, let's say, cryptocurrencies where they made money and whatnot. They're kind of transforming that into data centers. So how do we bridge that? How do we enable that? So if you take a look at now, these kind of products, the one on the left side is where we have the GPU platforms, but they need to be cooled in a different way. In a traditional data center, you probably use something like liquid to air, which is, think of like a big radiator sitting next to the rack of servers, right? Versus the ones that are actually using liquid, basically things coming to a chiller, where we can actually use some kind of an in-rack or in-row CDU, sorry, the heating distribution units, right? So then what happens is that you'll be able to handle the systems, all the cooling requirements in that. But then on the far right is what we have. These are called the water towers or chillers, right? Besides the HVAC, these are things that are needed. And let's say, for example, I was born in Hyderabad, right? So in Hyderabad, we don't have as much water. If I put these chillers and then I start running water, the first thing they are going to do is kill me, right? I mean, we don't even have water to drink, and now we are talking about these, so which is not good. So we need to have dry chillers for that. So depending on where we are in the part of the world, we need to look at what are the requirements, and based on is a dry cooler or a wet cooler or a hybrid manner, and be able to roll that in the data center. And okay, now we talk about all these things, but what are these systems looking like? So typically what we are used to is the rack mount systems, whether it's Intel based or AMD based, either 1U or a 2U type of form factor. These are form factors, right? And the second thing is related to multi-node. Most of the people that are involved in the high performance compute know this. The dense compute with highly connected interconnect fabric, when you put it together, these are the ones that are being used. Then the GPU servers. I'll have my colleague to go into details on what all the things we are doing on the GPU side, but typically a PCIe based accelerator or a highly interconnected ones with like NVLink or OAM form factor. These are the type of GPUs that are being used. And then on the far right, what you have is basically racks of systems where the entire rack is a single system. You may have seen something called Grace with Blackwell, like a GB300. This is one type of thing, and Helios. Those are the two that you can think of in those lines. All these things need to be connected with a good amount of storage, because it's impossible to handle these large models without having enough high performance storage that is closely connected to the compute. So this is basically the product portfolio, how it's going to look like that are going to go in a data center. Now, what does it mean? So we need to start looking at systems that are at a system level. And from a system level now, we're starting to look at the systems at a rack level. When multiple racks are put together using fabric, and these things are connected to other storage and other infrastructure within a data center, and then it's connected to chillers or whatever outside. Think of it in a holistic way, right? But now, when you connect these many systems, how do you ensure, how do you manage them, how do you provision them? This is a big headache, right? For a compute infrastructure point of view, many people that have been handling this for a long time, they know. But now we are talking about neo clouds. We're talking about the companies that are never ever touched the data centers are getting into this business. So it's important for us to provide them the tools to manage this infrastructure in a eloquent manner, right? So that's basically what we are trying to do on that front. So this is what we call it like a data center building block solutions. So as I mentioned, the systems when you have, especially, if a single system you take it, you have a processor and a CPU, and you have GPUs, and we have some kind of VRMs, and then you have add-on cards, which could be either Ethernet or InfiniBand. You have storage controllers. Everything will have its own firmware, and you have BIOS. All these things need to be updated periodically to get either maximum performance, or in cases where there could be security flaws that they need to be updated or patched. So when you're talking about one or two systems is easy. Now we are talking about doing hundreds or even thousands of systems, especially when you're talking about deployments that are happening at a giga scale. So this is the reason we started investing quite a bit on a system management tools, be able to manage and provision as well as updating this kind of infrastructure quickly. So then, now I mentioned about system management, but now we're talking about data center level. So how do we do that? So at the very base level, if you think about the racks at the bottom, the easiest is to talk about the system administrators that have access to these tools to go and manage the systems. But then, when you're talking about multiple systems in a rack or in a data center, how do we handle that? Is a data center operator headache, right? But then, many of you coming from the software side, now you know it is going to be about the developers and how they can have access to these systems. So it's about the DevOps is one of them, and it's also about providing tools, for the developers when they're developing something natively on the cloud. So then this is more of like just giving you an idea of what are the other things that one should be considering. Global services. Things will break, especially when you are using at a, I don't know how many of you are from hardware engineering, but things will fail at a GPU level or an interconnect level. There could be signal integrity issues. There could be mechanical issues. There could be so many things. So obviously, the telemetry and diagnostics is part of it. But when things fail, how quickly are we going to be able to fix it? Let's take an example of a GB300. We're talking about roughly $4.5 million per system. If it goes down, $4.5 million is not being in production, which is not good. So we need to be able to very quickly bring it up. This is the reason on-site services come into picture. One can make an assessment to see what it is, and we'll be able to either support directly or through our partners. At the same time, when you are bringing these kind of clusters, people haven't deployed them at scale. So I think Suresh mentioned in the beginning that we are one of those very few, if not the only one, as an OEM, have deployed at a gigascale data center. And the public information is that we actually are the ones that enabled Elon Musk with the XAI, right? So this is the reason. It's not easy thing. There are a lot of things that go wrong, but we have learned what to do, what not to do. This is the reason we are saying like, okay, maybe we should start helping our customers from the deployment point of view. This is where the deployment services will come into picture. Again, India being one of the markets where we heavily work with our partners, will be either using our own resources or our partner resources to go do that. And then this actually provides a way to optimize the clusters and bring the right performance to that. Now, just to kind of give you a summary of what's happening, typical data center. So, you have some kind of transmitters, and then you can get the power into that. Local transformers that is providing power. This is the infrastructure space that's happening. You have existing cooling, as well as you are able to bring water towers and all that to make it. So what is happening on that? The first thing is, in a data center, you have right now, you have compute, and you have storage, You have networking switches. You need to find a way to cool it down. At the same time, the cluster and cluster management. So this is what basically goes within the data center. So what happens? You need to enable it with power. The power has to come, without nothing works. What the output? Number one, heat. That's not something we want. We want to reduce it. The second is data. In an AI data center world, it's nothing but tokenized, right? You're talking about, I give you electrons, you give me tokens. That basically becomes an AI factory. So how we are actually looking at it is, in each of these things, what we are going to enable our customers with. So let's take an example. In this case, you need to have power. Power could be coming from more than one type of sources. And we need to be able to accommodate that, and we need to be able to roll it into our management tools so we can still provide a single pane of glass. Similarly, you take a look at on the cooling side, you have either a dry cooler or a mechanical or a water tower, whatever it may be. And we need to be able to put a way to put the software that is managing it, and we need to be able to give help in developing these data centers from ground up, and as well as help with the customers on building these complex clusters with the cabling and telemetry associated with it to handle it, and the data center build happens. Will all of this can be done by a company like single company like Supermicro? The answer is no, right? This is where the partners and the partner ecosystem comes into picture. At every one of these stages, there are more than one supplier. It could be Supermicro, it could be one of the partners. Our job is to make sure that we understand the end-to-end how it looks and what is involved, and see who are the major players in that. That way, when we enable it and then we are helping customers, parts of the building blocks will come into picture from Supermicro. Parts could be coming from partners. That's number one. Second is, when we are putting it all together, how do we ensure that it is going to work? That's where a bit of work that needs to be done from our friend. By doing all that, we are able to enable the data center from an empty shell into something of an AI factory that is going to provide tokens in a most optimal way. This is the effort that we are putting. So beyond a server, how do we enable data centers, especially in a country like India, where we are talking about massive, massive investments, and much of it will be borrowed as a money, and how do we enable these guys better? This is the idea for that. And that is part of my presentation. But in terms of the products, what is actually enabling us to do that, I'm bringing Alok Srivatsav, who is actually a product manager that is focusing on GPU products and AI products. So he will go into the details. Thank you very much.
Thanks, Vic, and thanks, Suresh. So to begin with, Vic has pointed out this one that we are building AI factories now. And my name is Alok Srivastav. I am Director AI Infrastructure, Supermicro. So, India, right now we are talking about a new chapter that is democratizing AI. And it's a AI Impact Summit 2026, the first in the Global South. And the theme is really wonderful and very noble theme, that is welfare for all, happiness for all, based on three major pillars: the people, planet, and the progress. So when we talk about progress, everybody knows that the most important driving factor for this progress is going to be AI. And when we talk about AI, so in last few years, significant improvement have been made in this particular field. Especially, it's sort of a paradigm shift. And when we talk about paradigm shift, we are talking about multiple inflection points. So the very first one was just, few years back, that was, in fact, the exact date is 22nd of November, 2022. The date when OpenAI, they introduced ChatGPT. And that day is pretty much considered as the watershed moment in the field of artificial intelligence, because that was the day everybody realized what the power of AI is and what it brings to the table. The next one is the year 2026. Most of the market research, it indicates that this year 2026 will be marked as the year of scale. When we talk about year of scale, the reason is very simple, that now AI is moving from experimental tool to infrastructure utilities, what Vic was also mentioning about the AI factories. So the most important, factor is inference, because this is one of the most important workload, because in inference is where the end user meets the application. And at Supermicro, we are building these AI factories for this industrial era with full responsibility and energy-aware AI. So how we do that? So you all know that you all might be aware that at Supermicro we have one of the largest server portfolio in the industry, and these are some of the product families. What Vic also mentioned about this one, and under each product family we have multiple options. So we have multiple options under each product family, and especially today, we are going to talk about the GPU servers, because this plays a very important role, vital role, especially for these AI workloads. Broadly, it can be classified into three major categories. The first one is HGX, PCI, and MGX. The HGX one is playing very important role. Whatever you see AI is doing right now, the HGX-based platforms, the OEM-based platforms, these systems played a very important role. The PCI-based systems, these are pretty much very flexible systems. These multiple different type of accelerators can be used on these platforms. And last but not least is the MGX. We work very closely with NVIDIA. So these are the systems especially designed for the accelerators that is based on NVIDIA. So how we do that? Because we always claim that we have one of the largest GPU server portfolio in the industry. So the reason is very simple. The answer is very simple. That this is based on our design fundamentals. And Supermicro's design fundamentals are that it is based on building block architecture. And because of building block architecture, we can just configure the systems in different ways. And that's how we come up with multiple options, not just to confuse customer, but to provide them the exact solution for their specific needs. So real quick on this one, so Supermicro, you have seen, Vic also talked about that one and earlier also, that we have a huge range of these systems, but all these systems, what we are talking about is specific to AI. We are very deep rooted in this particular type of infrastructure. Right, starting from the first one, the very first one that you see on the screen, that is DGX1. And the DGX1 is the system that Jensen, so many times, you might have heard, he mentioned about this particular system, that this is the first system he delivered to OpenAI. So this is the very first system from where this, all these, the major changes that you see in the field that is started. And followed by, the A100s, the B100s, B200s, and finally, the B200 that you see at the bottom. And the performance difference you can see, it is started with 1 petaflop, and as of today, the most advanced chip that is based on this, the B200 Blackwell, that can generate up to 144 petaflops of compute power. So humongous change, humongous improvement in terms of compute capabilities. So that brings us to the next one, that one of the most advanced chip right now available in the market, that is Blackwell, the B200s, B300s. And there is a significant shift between B200 to B300. And B300, you can say, is pretty much the most fundamental or the purpose-built systems, especially designed for this type of workloads, what we are talking about. AI factories, everybody is talking about AI factories. So this is the fundamental system from where this journey really starts. So the timing is perfect. These systems are purpose-built systems, especially for AI factories, the one that you see at the bottom, the B300-based platforms. So here you can see, we will talk a little bit more about the HGX-based platforms. These platforms are very important because these platforms are the fundamental building blocks, as we mentioned earlier. And all the data centers that Vic also mentioned, that pretty much all data centers, they are power limited. And in order to get the best TCO out of it, it is very important to use that power envelope in the most efficient way. And the one that you see on the screen, this particular system is based on our liquid cooling technology, that is DLC2. So before this, the system is successor of the previous generations, the hoppers. What we were talking about earlier, the H100s and H200. We will we will, disclose a little bit more information on that one, that how we really, really did well, and we created a very good, example in the industry that we did those deployments at a very, very fast pace. So this system is a next level. It's improved a lot from the previous generation, which we already did, the hoppers. And here, this is DLC2. So the key difference is that earlier it used to be only the CPUs and the GPUs, those were liquid cooled. But this particular platform, you will see that it is not simply the CPUs and the GPUs, but also the DIMMs, the VRMs, even the power supply is liquid cooled. So these systems, they finally, at Supermicro, we always provide that them in full rack stack cable labeled solutions. So you can see on this particular, there is a rack, most optimized one, it is going to be 8, but it can go beyond that also, less than number 8. But it finally, the most important thing is it depends how your workload is, how the design is. But this particular architecture that you see is the most optimized one. So in terms of performance, what we were talking about earlier, that is capable of generating 144 petaflops of compute power. And same thing applies to this one. This is a 2U system. So this particular system we recently introduced at OCP just a few months back. And this system is gaining lots and lots of momentum, lots and lots of interest in this particular system. The reason is simple, because with this system, you can, if the given that you have power available in your data center, you can pack the maximum density at a rack level. And what we mean by that, so you can see here, you can put up to 72 GPUs in a rack, which is very similar to the most important and the most, the famous architecture that everybody is aware, GB200, GB300, NVL72s. So here you can see that, okay, this system, with this architecture also, you can put 72 of these GPUs in a rack. The key difference is this is for scale out, and the GBs and all this stuff, what we see, that is for scale up architecture. So that is the key difference. And lots of customers, they are still on x86 architecture and want to capitalize this much compute density. They can definitely go with this particular architecture. One very important difference is this is not 2U, this is 2OU. So here the width is different. Instead of 19-inch, it is 21-inch. And it is, especially for, it is based on ORV3 rack design and all this stuff. It follows that. And the key difference is that TAM is increasing as well, because you see that lots and lots of it is, we are talking about the scale. So it is percolating from hyperscalers to neoclouds, and from neoclouds even to enterprises. So in our customer base, there are some customers that is basically they are enterprise customers, but they are also looking for this particular architecture. The reason is simple, because their data centers are new and they want maximum density. So how you can do that? So you can simply double this density. So you can see in a rack at Supermicro, we were the first one, and that's why we were getting very lots and lots of traction at OCP also, because we can pack up to 144 GPUs in a rack. So in terms of compute capability, it can generate up to 2.6 exaflops of compute power just in a rack. So the next one is, as you see that lots and lots of data centers still, even today, even in US, across the globe, they don't have liquid cooling capability available. So they still go with the air-cooled version. So this is the system, the air-cooled version. And in terms of compute capability, again, it is same, 144 petaflops of compute power on this particular platform also. And this is, this particular system, this architecture is based on our previous generations of our flagship products, starting from the A100s, the H100, H200s, and so on. So the next one, you can see that again, the most optimized configuration, because of power and all this stuff, it is going to be 4 systems in a rack. And this can be up to 60 kilowatts, just at a rack level. So the next one, you all might have heard of this one, the GB300 NVL72s, lots and lots of buzz around this because of these, the latest workloads. And the key here is that this particular system is very complex, very complicated. And at Supermicro, once again, we are working on some of the world's largest deployments that is under process right now. And pretty soon, we will be able to share with you few more success stories based on this particular platform, because this is very complex system, and because of Supermicro's past experience, we could make it happen that we are again doing this deployment in a record time. So you can see the gradation, how it started earlier. It used to be just 20 to 25 kilowatts racks, and now you can see at what pace the rack capacity in terms of the how much compute capability you can pack in a rack, and where it is going. So where we were, where we are, and where we are going. So this is a clear example. So here, as of today, it shows the maximum is 227 kilowatts. But still, there are some designs we are already working on that will go up to 400, 600, and even up to 1 megawatt at a rack level. So this is just to give you an idea. So the systems earlier we were talking about, then it goes into these racks, clusters, and finally these clusters. Just like you can see, just in this cluster there are so many the cables and all this stuff, lots and lots of work and lots of complication and lots of expertise is needed to make it work. And finally it goes to these the data centers, the multiple of these units, just like we call it a SU scalable unit. And multiple of these scalable units goes into a data center, and these data centers pretty much they are acting like AI factories. And the most important part here is that all this stuff what you saw so far that is needed, and we are building all of these type of deployments. And the most important thing is the workload. What Vic was talking about earlier, the workload is changing also at a very, very fast pace. When we were talking about ChatGPT and all this stuff, so it was just 1.75 billion parameter, 175 billion parameter models. And today we are talking about 10 trillion, 6 trillion is already out, and 10 trillion is coming out pretty soon. So lots and lots of compute is needed. Whole data center acts as a building block. And so we started, with this concept that, okay, the whole data center is a building block solution. And the success story, what Vic was talking about earlier, it was not, but now it is pretty much a known secret. Everybody knows about this one, that the world's largest deployment based on liquid cooling was done by Supermicro. It was 100,000 GPU cluster. The first 50,000 were H100 based. The second 50,000 was H200 based. So the total 100,000 GPUs cluster was deployed just in 122 days. And it was definitely, Vic already mentioned, so this was done for Elon Musk, his company, XAI. Now, so far, all the systems what we were talking about, this is where we were, where we are, and where we are going now. So the next one is going to be Vera Rubin. Vera Rubin, as you know already, you might have heard a lot buzz about this one. So this is going to be even more complex, more complicated system, because lots and lots of changes already happened on this one as well. So first of all, there are 6 changes, all the major 6 chips, they all are pretty much, the latest ones. So all that is changed. And the most important thing is there is an architectural change also. Now we are talking about KV cache. You might have heard of that one. So we are talking about this generative AI-based inferencing that is not simply a one-shot inference, what it used to be, but it is now sort of a thinking process. So for that, you need lots and lots of memory, and for that, the KV cache part is also involved in this one. So that is going to add more and more complexity to these type of architectures. The next one is very important. So far, it is mostly about the compute, the training, and all this stuff. But AI is incomplete without the visual computing. So visual computing is going to play a very important role, vital role. Without visual computing, this AI is not possible. And the most important thing that is going to happen, that the next wave of AI that is going to disrupt the world's largest industry, that is heavy industry. So for heavy industry, this visual computing is going to play a very important role. And finally, you all are hearing about this, the agentic AI and the reasoning models, the robotics, and the physical workers and all that. So pretty much, for this next wave of AI, things are already percolating to that level, and it is going to be the biggest disruptor in the industry. For that, again, purpose-built systems are needed. So the one that you see on the screen, this is one of the most advanced building block solution that is available for this visual computing, these type of applications. This particular system can be powered by 8 RTX Pro 6000s or H200 NVL, those type of GPUs. So this system is capable of generating the maximum compute capability at a node level. So earlier, Vic also mentioned about this one, that at Supermicro, we are considering the whole data center as a building block. So if we are talking about whole data center as a building block, so it starts from the system level, what we were talking about, then it goes to rack level, cluster level. And Supermicro is the only vendor that gives you end-to-end solution. And other vendors, they also talk about end-to-end solution, but our ends are different. Our definition of ends are different. For us, it is from cold plate to cooling tower, the one that you see on the extreme right. So from cold plate to cooling tower, everything from Supermicro, one throw to choke. And this is a little bit more details about what is covered under DCBBS. So all these, the services, the liquid cooling part, everything pretty much, it's a body of work that what we do at Supermicro. So that pretty much, encompasses in this, the DCBBS solution. So it's a framework, basically. It is not just, it's a framework guide designed without being prescriptive. So we are open. Generally, we are, working with customers. As Vic mentioned, they have money and they don't know exactly, how to reach to this final thing. So Supermicro is working with those type of customers also, and there are customers who know exactly what they're looking for, and something in between. So we are working with a range of customers, just from who needs handholding right from the beginning to the expertise. They know what exactly they are doing. They, in fact, tell us what exactly they want, and we make it happen for them. And in between also, if there is any gaps in between, that also we can provide. So end-to-end at different levels without being prescriptive. So that's what Supermicro is. That's all from my side. Namaste.
So Suresh and Cambiz are going to come upstairs. Let's ask some questions. So I know it's a lot to grasp, right? Because especially for us, we are living and breathing this, so we know. But at the same time, for many of you, it may be new, or maybe I don't know, right? But the idea again here is to take any questions that you may have. If we know, it's great. If we don't, at least we know what to work on. But let's go with that. And if you have any questions, please bring it up. I don't know if there's another microphone that can be given. He's bringing it. So in the front row, yes, go ahead.
Hello. Yeah. So as we know that in server side, there is a lot of latency due to I/O delays. So is Supermicro working on that area? How we can reduce delays? Like for example, PCIe. So they have their own delays. So some kind of future generations like photonics. I think there is research going on for photonics kind of interconnect. So Supermicro, is there any kind of work happening on that front?
What is happening in the industry right now is that bringing the packaging where the silicon photonics or even the connectivity directly to the chip, which actually will improve the throughput as well as reducing the latency, also reduce the heat that typically comes from the optical components, right? Much of this actually happens in the silicon vendors. So what we are doing is to work with them, right? So for example, if you take a look at NVIDIA, their GPUs are connected using NVLink as a connecting fabric. The latest generation they're talking about 3.8 6 terabytes per second is the throughput between these GPUs. I'm talking about Vera Rubin, right? Similarly, if you take a look at AMD, they use the Open Accelerator module, which is the OCP standard, which they are connected using that fabric, right? You are absolutely right. If you take a look at the PCIe, PCIe Gen 6, even Gen 7, and when it comes, while the throughput is there, the latency point of view, it's still going to be one of the sticklers. What is happening is that you need to look at it in a slightly different way. For training models where there's a lot of data movement that's happening between GPUs and across multiple systems or GPUs, this is where the latency becomes much bigger of a headache because the model does not fit into a single GPU. Versus the trained models, if you are using for inferencing, much of the data actually fits within the GPU main memory. So what Alok showcased was like 288 gigs of memory that is sitting on a GPU. The model fits in, the inference does not need to go and pull data out from a different GPU. So short answer is Supermicro is involved indirectly by working with those silicon partners to bring the technology into our platforms. But other way to look at it is it all depends on what application that we are trying to do, and based on that, which interconnect fabric that you need to take. Because mind you, advanced technologies cost more money also. We need to see how the ecosystem need to be fully utilized. Do you have anything to add to this?
So there are several ways of handling this type of challenges, and one of them is the numerical formats. So to answer your question, the new numerical format that is being introduced, that is NVFP4. So with using NVFP4, so multiple, the key reason is to reduce on the latency and make it happen, faster. So from all fronts, increasing the memory, we were talking about KV cache, right? So KV cache, NV, FP4, and FP4. Earlier it used to be simply FP4. Now it is NVFP4. That does the dynamic allocation of the different numerical formats in order to take care of this, the latency part.
Yeah, hi. My name is Aditya. I work for a company called E2 Solutions. We are basically into PLCs, Allen Bradley's and Siemens PLCs. Just wanted to understand from a data center perspective that what is the cost allocation of different aspects that you have in your data center, and what kind of investments are we talking about here in India that we are looking at to set up a data center here?
So the yardstick is about 30% of the total infrastructure. The yardstick is typically 30% of the total infrastructure goes into the data center build out, right? So what it means is that the shell of the data center, the power delivery that is coming into that, and as well when you're talking about the CDUs, CDMs and things like that, as well as the UPS that goes into that, depending on all those things, that is basically around 30% of it. But it's changing rather quickly because it all depends on what you put in the data center. So for example, in a traditional data center, that's what it is. If you go into the AI data centers, instead of, let's say, a $4.5 million product, suddenly if it becomes $9 million, then the equation actually drops on that front. So when people talk about a gigawatt type of data center, right, the power is one of the, let's say, on the operational expense side of it. Normally it's what, 7 rupees per kilowatt hour for many of the data centers here in India. Now you need to start looking at whether you are using or not, are you paying for it? Because it depends on the source of the power, right? But as the data center is concerned, again, where you are building and whether any local subsidies that are available, a whole bunch of stuff, right? I can't hear you, sorry. So, Ratmeshwar, who is the one that's carrying the microphone? Can you give it?
Can you just take an example and share, like, what exactly are the typical costs, like, not only of the data center that you have the cooling systems that you have there, right? You have a lot of heat exchange systems there, input power generation systems that you have. Approximate cost and, split of that cost, so that, we are able to understand if we are getting some investments here, what exactly are we looking at?
Right. So basically, I think that's something that we cannot directly give that it's cost function on that one. We can actually take a specific use case. We can take your contact information and work on, let's say, for example, if you're talking about a 50 megawatt data center, what are the things needed? We can kind of spell it out on that front. That's easier way to do that. things.
Yes, sir. This is Omlan Sharkar. I'm from West Bengal State Electricity Distribution Company. We have a conventional data center, let me tell you first, and you have changed whole of my idea today. So as you are talking about 250 kilowatt a rack, my whole data center is having a capacity up to 250 kilowatt. Now, I have seen the PPT that you have given. Give me an idea, as you have talked about 250 kilowatt per rack. So, what kind of energy you are using? What is your backup power? Say, are you using green power, or what is your backup power source? Is it running in DG generator or any secondary source? What is that?
So, couple of things. Number one, 250 kilowatts is not bad, my friend. I mean, it was the thing that was actually all of us grew up on, right? In the last 2 years, it kind of makes us look, oh my God, what happened? The point is, there is still a significant amount of standard compute, CPU-based compute that's happening where majority of the workloads can still run. So that's number one. Number two, when it comes to the power, it ultimately boils down to the data center operator where the power is coming from. So let's say, for example, in your data center, you want to retrofit, and you say, like, you know what, I want to use all my compute and storage as they're coming in, but I would like to add some of these advanced GPU clusters. Now, what happens when you do that? You need power, and you need cooling. You need to figure out a way to do that. Now, you need to start looking at where is it coming from, right? So if you start taking a look at, let's say, for example, West Bengal, if there is some hydroelectric plants, you take it and the grid is there and you bring it and you put a substation and you get the thing done, fantastic. But what if you need something in the next 2 months and this thing takes like a year and a half in getting the approvals and compliance, clearances and everything? Then you will not be able to use it. Part of the reason why is because like then they say, okay, I can bring some turbines, I can actually have a diesel generators to basically bridge the gap until my standard power delivery will come into picture. So it ultimately boils down to what is available, and within that, what you choose. My hope is that, there is enough renewable energy that is going to come in India, either through solar or through, wind or any of it. Although it's not sustainable, right? I mean, solar only in the daytime, wind, I don't know when it comes. But the idea is to use however much that we can from the renewable energy, which is going to be good, because the amount of power that will be needed in the next few years is going to be insane, to say the least, right?
But presently, how you are operating? You are operating in...
I don't operate at a data center. I actually work with data centers, are a customer such as you, and say like, okay, these are the potential options that you could consider in order to bring something into your data center, right? Our main core competence is actually making the compute or storage or networking that goes within a data center.
Okay. But do you have any idea what kind of power they're using right now? Or whether they
in
have...
India or where? Because we have...
In outside also, whether they have any battery backup and how long that is sustainable?
Yeah. Battery backups are basically used as a transient. In other words, let's say, for example, in a large language model training, when you are doing it, there are a lot of spikes. So in order to handle the spikes and not to load the grid is where the battery backups are there. Like, for example, Tesla has a mega pack that typically provides that people put outside the data center. It takes care of the spikes. But otherwise, what happens, your generator will get wrong signal. Should I make it or not? And by the time the generator either picks up the signal and starts making, other spike may come and do things in a different way. To answer your question, it's a combination of various things. There is no 1 or 0 answer for that.
So it's a mix of carbon energy as well. Okay.
Absolutely.
Thank you.
Thanks.
Hi, thank you. That was a very meaningful presentation. The question that I was trying to ask is that from an overall net zero implication point of view, is there a growing sensitivity overall at a national level that this needs to come in as one of the primary sources, given the appetite for AI models and the way that we are consuming it? Because each of us know the amount of tokens we are passing on, etc., etc., without being oblivious of the amount of energy consumption that is actually happening. So how is it that you all are seeing this sensitivity towards this cause actually rising across the organizations, and is this moving towards something more measurable and tangible as we look forward?
very, very close and dear to my heart type of topic, because we always are looking at energy efficiency as one of the key ways to reduce the power consumption. So think of like within a given power profile, what's the maximum throughput that we can get. That's also a way to look at it is, in a typical data center that's running at like 1.6, 1.5 as a PUE, or the power usage efficiency, 50% of the energy is being burnt just in, kind of cooling the systems, right? By improving the efficiency and making it run at a higher ambient temperature, or using alternates like liquid cooling and whatnot, we are able to, in a way, slow down the carbon footprint in a way. Many companies actually have anywhere from 2030 to 2050 time frame for carbon neutral or a net zero. But the AI is coming in completely a tangential way, in a very big way. So which is putting definitely a lot of strain on these companies. But what is happening is many companies, because of their own initiatives, they say, I need to take this much of power from renewable energy. In fact, that is also one of the reasons where people are moving into different countries where the renewable energy is readily available, such as Nordics, for example, where environmental conditions are a lot more conducive to that. In India, what I see is that we have enough sun, and then we also have enough water because of the dams and everything. People can actually use different ways of doing. In fact, I was talking to some of the energy companies where they are using dams to basically pump the water. Like think of like a closed loop where you have a big pond, below the dam, and then you pump that water up into the thing, so it becomes a static energy. And then in the nighttime when it's needed, when there's no sun, you actually take that and then go create the electricity. So the answer is that there is going to be huge investment that would be needed, and I think companies will be forced to, because of the government regulations also. Because the Indian government is also pushing for renewable energies and making things more efficient. As a part of it, as the scale increases, then the cost becomes more reasonable. So private entities can still run a profitable business by adopting green energy. So I'm still sincerely hoping that is going to further accelerate and get adopted. Thank you.
Hi, my name is Sucheta Chitgopekar. I'm a patent lawyer from Chicago. We do a lot of patenting in this area. My question is, have you considered placing the data centers in colder region to take advantage of the cold air and circulate the ambient air for the cooling purposes?
It's happening actually. Like most of the times what ends up happening is, so let's say, for example, I go and put it in, I don't know, they're going to kill me, but let's say Antarctica, if I were to put it. It's very, because Arctic is melting anyway. So if I put that, it's cold. But the point is, how am I going to pull the data out? I need to basically have cabling all the way there and do that, right? So there are different regions in the world where it's nice and cool, and it actually, without impacting the local environment much, we can run it. But there's an additional infrastructure spend that is needed, which will eventually get there. But what is happening is Nordics, as I mentioned, is one of the growth areas. I think 2-3 years ago, a lot of people were talking about Iceland, and I think it's kind of getting capped out. Now they are going into other regions. But unfortunately, we want to bring the business to India, and I don't want to go and put it in Himalayas either, right? So the idea again here is to figure out with what we have. We have enough sun, we can create electricity with that and figure out a way to do that. And if you're doing it in coastal regions where you can potentially use the water from the ocean and pump it and do things like that, I think there's going to be a lot more innovation. I think the one good thing that we have plenty is a lot of smart people. I think we can actually figure out ways to do that.
Hi, my name is Adesh Tyagi. I'm from Bay Area, where Supermicro is from. We are looking to establish large data centers, 500 megawatt plus in India. That's why I came here. How much of the capacity you have installed so far in India, and where?
So if you take a look at entire India, the public information that's available is like less than 45,000 GPUs that are deployed. So much of it is going to be in future. So what happened so far is only like in tens of megawatts, right? That's the reality of it. And the second thing is that off-taking is typically going to be on inferencing. And where what I see is that multiple enterprises and whatnot are going to be using them, which are smaller footprint. What I do see, such as yourself, first of all, thank you for doing something in India with the larger deployments. I have seen several initiatives running from few hundred megawatts to a gigawatt plus that's happening over the next 2 to 3 years, assuming that there is an offtake and makes a business sense and whatnot. So what we have done is a part of those 40, 50,000 GPUs in India. It's not a huge number compared to 100,000 GPUs or 200,000 GPUs that are getting deployed in some of the other parts of the world, right? And that's why I think the whole AI, the summit that's happening right now is very important, because there is a gap. We have a lot of talent, but we don't have the infrastructure. We don't have an off-taker that is coming from India. So when you take a look at the subsidies that is being provided by the government recently, I think the tax break until what, 2047, something like that, some 20-year tax breaks, and reasonable amount of power, lot of talent. All these things is hopefully going to bring the infrastructure players to come here and start deploying things, so it can be a very, very powerful player in the world stage. Otherwise, what happens? The technical, the services type of arm that the whole India was very popular. If some of that is taken by AI, then the economy, what is that we are going to do? So I think it's very well positioned in terms of technology and the power and then the stability of the governments and everything. So we just need to see what we can do on that. Any other questions?
Yeah, hi. I'm Ish Bhargav from Electronics and Semiconductor sector. First of all, it's a great session. Amazing, information you have provided here in a very nice fashion. One question was that can we extrapolate it, or if you already have the full knowledge, systems like Cerebras, like wafer scale engines, how much they are able to achieve in terms of petaflops per rack and how much power they, so any insight or, you can.
I mean, it's easy to do. Luckily, all the chat GPT and anything, so you can just drop a question and they will be able to do a comparison. But what's happening is the larger the models that we are doing, and the cost per token that is going to be driving the ecosystem. So if I were to take a step back, NVIDIA, of course, is the de facto standard. We have 90%, 95% of the products based on that. We are working with the likes of AMD, and we are also working with inference partners such as Furiosa AI and Rebellions and things like that. All of these things, why I'm mentioning that is you take a look at many of the models that are primarily driven by the CUDA as an underlying infrastructure. On top of it, whatever the layers that you put on that, it's working. That comfort is what mainly driving people for something. But then, for those who are actually having the technical resources to go and run this infrastructure and develop some applications on it, Cerebras and all these are fantastic solutions. So I have seen, for example, them doing in Middle East as well as in some of these national labs and other things in US quite a bit. It ultimately boils down to what works out best and whether people have resources. At one way, people are saying, I want to deploy it like yesterday. So then you need to look at what works for you. Versus another aspect of it is and I have a reasonable cluster and everything is running. Now I have to go back and see how do I optimize my cost function. Then this alternatives is going to come in. So I think it's going to be in the effort to things getting democratized over a period of time. You will have more players coming up with different differentiated solutions for applications, and that's what is going to drive it. That's my take.
Thanks. One more. You want to add one more question? Follow up to the gentleman's. So this 50,000 GPU deployment has been done by Supermicro. Is that?
That's what I have seen deployed in India.
By
A part of it is by us.
Oh, great. That's very good. Thanks.
Thanks. Anything else? So we have Cambiz. I haven't introduced him at all. He's a vice president of sales, and we brought him in from San Jose. So in case if you have any questions related to what's happening in India with respect to the business and what potentially you need something, he'll be more than happy to address it as well.
All right, hello everyone. My name is Cambiz. As Vic mentioned, I am out of the headquarters in San Jose, California. So very happy to be here. It's a great event. Thank you to all the presenters we've had. We look forward for all of you to come to our booth and see all the different solutions that we were talking about today. We have our full team there as well, who's covering the India market. So please come by, stop by, say hello. We'd like to meet all of you. All right. Thank you for all your time today, and we'll see you in our booth. Thank you.
Any more questions?
Hello, I'm Kritik Sharma. I wanted to ask, like, with HBMs, they are going to a stacked architecture. So, is it also cooled by the liquid cooling method you mentioned on the slide, or that needs to be addressed with the air cooling only?
So if you take a look at the GPUs, let's say, for example, uh, you take a look at NVIDIA B300. The NVIDIA B300 is a 1100 watt per GPU, right? It has the GPU. Also, it has its own HBM3 memories. It is offered both as air-cooled or liquid-cooled. So basically what it means is in an air-cooled environment, if you're running those systems that we showed, like a 8U or 10U systems, it's using air, it's being cooled. On a liquid cooled environment, the cold plate actually covers that as well, which takes care of cooling that using liquid, right? So both of them. But as things progress and more layers are going to be formed, obviously you need to take the heat out more efficiently, in which case it will eventually get into a point where it will be liquid cooled. Maybe Alok can allude to that.
Yeah. So good question. So in fact, with our next generation, it is liquid cooled. The next generation, the system I was showing, so that is liquid cooled. The memory is also liquid cooled. Yeah.
Bottom line is it can be air or liquid. That's number one to understand. But as more layers, like today, it's like first stacks were like 8 stacks, then it became 12, as it going to 16 and all. Now you need to figure out a way to efficiently cool it, in which case, eventually it will go to a point where it will be liquid cooled altogether. Anything else? Anybody still awake? So thank you very much. Please, I mean, we are looking to see a lot more coming from India, especially with respect to AI. A lot of talent is here, and then, anything that can actually be done here that's going to be helpful for all of us. And thanks for giving us an opportunity and sitting through this presentation. Hopefully you kind of got a better understanding of what Supermicro is and what we are headed. And there's going to be continuous changes. If it were to be a follow-on for this event next year, maybe it will be a completely different story. So we need to continue to stay relevant, stay active and aggressive, and we'll all be good. Thank you very much. Bye.
Mr. Rajan. Hello, hello.